We have up next Peter Loveall AE5PL, and he is going to uncover D-STAR.
First of all, the first slide is just to give you a little bit of a reference to who I am. I am not part of ICOM, so you can rest assured of that. I have no affiliation with them whatsoever, other than I own a couple of their radios. But I also own a couple Kenwoods and a few other radios as well. Even a couple of Heathkits that I built myself. But K5TIT is the Texas Interconnect team. We are the early adopters of D-STAR outside of Japan. In other words, we are the early adopters. We are the first repeater sites that went in, both for the 1.2 gigahertz modules and as well as the VHF and UHF modules that went in outside of Japan. So that gives you a little bit of an idea, and as you can tell probably from the logo, we are Texas-based. We are based actually in the Dallas area, and I live north of Dallas, about 35 miles north of Dallas, and I use the 1.2 gigahertz D-STAR module at 10 watts, so that's not doing too bad. Especially if you've been to Dallas, you know there's no mountains there, so we don't get that. Okay, under the covers. What this is we're going to talk about D-STAR. I'm not going to talk about why it's done this way, or it should be done that way or that. If that's what you want to talk about, this isn't the presentation for you. What this is a presentation for you is so that you can understand what is in the D-STAR specification. And by the way, this paper is published in the proceedings. What is in the D-STAR specification, what are ICOM enhancements, and what it really all means and how it plays together. But it's more from a non-technical, using the technical as support, but it's from a non-technical standpoint. In other words, how do we use it? Is it usable? Or do we just throw it away? What do we do with it? And this is to give you an idea of how that works, not whys. As I say, if you want to discuss whys and debate whys, you can debate that with other people. I'm not the person to debate that with. I'm just going to try to tell you what it is and how it works. D-STAR is owned by the JARL, the Japanese Amateur Radio League, which is equivalent to our ARRL, except for one primary difference. The JARL is part of the Japanese government. Okay? So anything that they do, anything that they work on is actually part of the government, not part of an independent society. And because of that, there are some restrictions and things that we have to be careful of when we're talking with the Japanese, and as far as how this works or how that works, and understanding how their implementation and what they were viewing it as opposed to what we are viewing it as. It is not public domain. That means that it's not out there for you just to go and start modifying and say, okay, this is also D-STAR. But it is an open protocol. It is fully published and available. And if you can read Japanese, the entire specification is published. If you can't read Japanese, the RF specification and some of the networking part is translated into English. The RF protocol is actually published and also hosted on both the JARL and the ARRL websites. There are two primary pieces to the D-STAR protocol. One is the digital voice protocol, and I highlight voice there. That is the noun. Okay? There's people that think that if it says digital, that means data. That's not the case. This is a digital voice protocol. 3600 bits per second of the 4800 bits per second bit stream. Okay? Keep that in mind. This is a 4800 bit per second bit stream. It's not 3600 bits and 1200 bits or side by side or anything like that. This is a 4800 bit per second bit stream. 3600 bits per second of that is dedicated to the AMB voice codec and the FEC, forward air correction that codec uses. 1200 bits per second is dedicated to synchronization, some end of frame indicators, And also, then the rest of it is left up to be used by the manufacturers, programmers, whatever you want to do. ICOM has made use of it in such a way that we can have availability of an unprotected 750 bit per second serial data stream. Okay, not super fast, but guess what? What's the noun? Noun is voice. Okay, that's what this protocol is. It's voice. Can you do data? Yeah. Do you want to do data? Well, sometimes you do and sometimes you don't. We'll talk about that a little bit, but for the most part, this is a voice protocol. That's okay. They have a very good data protocol, and that's called the digital data protocol. Noun here is data. What is the data? Well, it's an Ethernet bridge. Protocol is basically an Ethernet bridge. Ethernet encapsulation. It relies on the Ethernet CRC for bit error detection. Currently, it's available only on the ICOM ID1 on 1.2 gigahertz because it's 128K. What they're doing is 128K transmission, and that's where their bandwidth was. It's bandwidth in Japan, things like that, availability, frequency availability, so that's where they put it. There's nothing that says that it has to be 128K, and there's nothing that says that it has to be on 1.2 gigahertz. The specification says that it's an Ethernet encapsulation. You'll see that. This is just where it's been implemented. On the ID1, it has an Ethernet 10 base T connection on the back. And the radio does not get any IP address. It doesn't know what an IP is. It has no idea. It has no idea what a MAC address is. This is Ethernet encapsulation. If you encapsulate, and you properly encapsulate, you don't modify the protocol that you're encapsulating. Okay? Guess what? The Japanese understood that. You don't modify the protocol you're encapsulating. That's what so they did that. They said that, okay, the radio doesn't have an IP address. It's up to whatever device you plug into that radio that gets the IP addresses and works from there. If you want to use IP. It's Ethernet encapsulation. In theory, you can use pretty much anything you want to. One thing I did put in here with regards to the ICOM, the digital data repeater is not a repeater. It was used, that term was used because of translation from Japanese. It's an access point. It's a half duplex access point. It's not repeating anything on RF. Okay? It's an access point to take it into either the Ethernet local area network that's there at the repeater module, whatever. But it is an access point. Okay, the top is the digital voice bit stream definition. The bottom is the digital data bit stream definition. What's highlighted there is something called the RF header. And this is also in the book, but if you take a notice if you take a look at this, just cursory look, you'll see that there really isn't any difference between the RF header in the digital data and the digital voice. There is internally, because obviously one's indicating that it's voice and one's indicating that it's data, but as far as the actual components of the header, they're the same. What this means is, to you guys as users, the gateway only has to know how to route one thing. It only has to know how to interpret one thing. There's no difference between the protocols. The only difference between the protocols is in what's actually carried in the data part of the bit stream. The other thing to keep in mind here is there is one RF header. There is not an RF header and packets and then an RF header and packets, RF header and packets. Okay? There isn't RF headers being repeated or packets or anything like that. This is not a packet protocol. This is a bit streaming protocol. That means all the identification, all the information that is used to identify where this bit stream is coming from and where it's going to is contained in that RF header. Because of that RF header, there's a little line underneath there that says error correction. 660 bits. Well, if you add up all the bits there that are there, and it doesn't come up to anywhere close to 660 bits, okay? The error correction, this does carry a forward error correction on the RF header, both in the digital data and the digital voice. It is that critical that they had to put in forward error correction to ensure proper reception of that RF header. If that RF header is not received correctly, then there is no knowledge of where that bit stream is supposed to go, who it's from or where it's going. To even help further with that, the RF header does contain a CRC, which is what they call the FCS. It's a CCITT CRC, 16-bit CRC. So not only do we have forward error correction, but we also have error detection in the RF header. I'm getting a pretty good idea that this thing is pretty important to the protocol. Okay, that's why. It is very important because all the information that tells D-STAR what it's supposed to do is contained in that RF header. Okay, RF header key factors. These are listed in the paper. Basically, just an overview. The flags, what kind of D-STAR information is it? Is it voice or data? There's other information in those flags that is defined, and it's actually defined in the DSTAR.pdf or showgen.pdf, depending on whether you go to ARRL or JARL's website to download. Your own call sign. That means that it's your own call sign. Use your call sign. This is not a place to use tactical call signs, okay? This is a place to use your call sign. This is your identification. All right. In theory, in the United States, yeah, you can use somebody else's call sign and identify over voice, and that's legal. Okay. But now, in essence, you've said that this is actually originating from one person. It's actually originating from another. So you got to be a little careful on that. That call sign, all call signs consist of 7 characters and 1 station ID character. All call signs. Sort of like AX25. All call signs in AX25 consist of 6 characters and 4 bits for a station ID. Okay? This uses 7 characters and 1 station ID character. And that is how it's defined. That's how it works. If you're not using a character, it's a space. Okay? It's not a null or anything like that. It's a space. And that's the way it's transmitted. That's the way it's received. It's always, it makes it pretty easy. It makes it pretty easy to understand. The one thing that they did do, that the Japanese did do is we're going to see, is for some repeater routing, they allowed a modification of that to allow the first character to be a special character. And that'll be and that's a forward stroke. But it's well defined in the specification. And again, what I'm talking about here is what's in this protocol specification, and I'll also talk a little bit about what's in the ICOM enhancements. Okay, the RF headers, I already said, protected by FEC and FCS, it is critical. It defines only the current transmission. In other words, if I transmit to you, for you to transmit back to me, and let's say you're in a different country, okay, you have to put my call sign in to talk to me. You can't just say, "Hi, I heard you," because there's nothing to tell the repeater system to send your bit stream back to me. Does that make sense? You understand what I'm saying? What I'm saying here is this is not linking. We're used to Echolink where I say, okay, I want to talk to somebody. And I punch in their code, or I go to IRLP and I punch in the code to link the repeaters. We're not linking repeaters here. I'm saying, who do I want to hear my bit stream, my voice or my data? Who do I want to hear that? And whoever's at the other end, if they want to talk back to me, are going to have to do the same thing. They're going to say, I want him to hear me. And if I don't want him to hear me, you know what? I just don't just put his call sign into my radio. Simple. He doesn't hear me. Unless, of course, you're on the local repeater system. In which case, it plays just like any other amateur radio, and that is everybody hears everybody on the local repeater system. But if he's on a different repeater system, if he's on a different repeater on the same repeater system, but on a different repeater module, he won't hear me unless I put his call sign in, or if I put the repeater that he's on, put that call sign in, and I'll show you how that's done. Okay, but again, that's still not linking. That's just saying, I want my bit stream to be heard by this person or by this system. Okay. Any non-protocol manipulation of those fields in that RF header, folks, you're breaking the protocol. Real simple. This isn't the AX25 game of, well, let's make up this rule for a digipeater, and let's make up this rule for a digipeater, and let's do this, and let's make the digipeater mean this, and the digipeater mean that. Nope. Doesn't play that way. Okay? And I may not look like it, but I predate AX25 by a number of years. I was using my old Model 15 teletype back in the early 70s. That was digital radio for amateur radio back then. We didn't have all this fun stuff. And when we went to AX25, we saw these digipeater fields, and we made them into nodes. We made them into this. We made them into that. Now, by golly, we can do routing this way and that way and every which way, but nope, that's not in the D-STAR spec. And if you try to do it with the D-STAR spec, you're going to break the D-STAR spec. You're breaking the protocol. And what that means is that you end up with similar things that we have with AX25, and that is it's too damn difficult to work with. You know, I may have some niche applications, but come on. And by the way, I use some of those niche applications, okay? So, well, but that is a key, okay? The next part is the network definition. This is very hard to see. It is much easier to see in the D-STAR specification, in the dstar.pdf or showgen.pdf, depending on which website you download it from, okay? Both in English. Bottom line, what this is trying to show you is that somebody can program in a call sign and they can talk anywhere in the network, and it will be routed to that person based on call sign routing. For somebody to talk back to you, they've got to do the same. And I'm going to talk about that in just a minute as far as some of the enhancements that have come along. To be honest with you, what this really is, I told you I predated AX25. I also predate the cellular network, which was actually in the mid-'80s. AX25 is actually older than the cellular network. We had something that was really phenomenal. One of my customers that I was heavily involved with in the switching operations and such had something that was really phenomenal. It was called Follow Me Roaming. Anybody remember that? Okay, what the real Follow Me Roaming was from GTE MobileNet? Real Follow Me Roaming GTE MobileNet is that I lived in Dallas. I went down to Tyler. And I dialed the number they gave me for Tyler that said, my phone is here, and now people could call me in Tyler. That's Follow Me Roaming. Now, it got more advanced because then the switch could figure out that you were there, and you didn't have to manually tell the switch you were there, okay? In essence, where we are with with call sign routing within the D-STAR arena is that I do have to tell the repeater that I'm there. It's a real simple operation. Click. Okay, kerchunk. And oh, by the way, that's illegal kerchunk, isn't it? I identified, didn't I? And I identified because what was the first thing that got sent out? That RF header had my call sign in it. So I'm legally identified, and guess what? That repeater and the repeater gateway said, he's here now. Put him in our table. Okay? All of a sudden, that's Follow Me Roaming in the D-STAR world today. All right? I want to call. I want to talk to my wife. I pick up a D-STAR radio and put in your call. I put in her call. And by golly, I can talk to her. And she can talk back to me because one of the things that has happened in the evolution of the ICOM radios is something called one-touch response, which will automatically put my call into the your call position on her radio so that she can respond to me. Okay? And it's called one-touch response because you do have to do something on the radio to make it happen, because you may not want to respond to somebody calling you. So you get the option. All right? But that's what this chart is. And this chart is in the ShowGen and in the DSTAR.PDFs. Again, DSTAR.PDF is available on the ARRL.org website. The ShowGen.PDF is available either, I'll show you on my APRS download area, APRS-IS download area, or it's on the Japanese Amateur Radio League's website. Routing factors. Okay. Own call sign, and in simplex we use own call sign and companion call sign. That's really all we care about. And by the way, the companion call sign, I don't have to know what your call sign is. I can just put in CQ, 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 and that is what CQ means. Okay? Hello? Anybody who hears me, feel free to respond to me. Local repeater use, you have to set the RPT1, the departure repeater, you have to set that to your local repeater call sign. Okay, why? Well, guess what, guys? This is digital. We don't have things called subaudible tones. All right? We don't have things like that to be used for signaling. We use that on our analog repeaters because that's the only method we have for signaling, right? Well, to allow for co-location and stuff, you set RPT1 to whatever your local repeater is. Now you have the ability to, you had to set the frequency anyway, so you hopefully know what their call sign is. You can set the repeater call sign and you're off and running. And you can use that local repeater. Yeah?
Why is it necessary to program the call of the local repeater? You'd think that when you appear on that frequency to that system, it would know who it is.
Because that's your digital code squelch. Think of it as your digital code squelch for the repeater. That's the digital code being able to tell it that it's the repeater, so that if there's a repeater 50 miles away that's on the same frequency, you're only bringing up only the local repeater that you're trying to use is actually coming up. That's why. That's a good question, but that's exactly why. Now, the next step is now I want to talk to him and he's in a different country. Okay? How do I do that? Well, it's pretty simple. I put in RPT2, I put in the local, not where he is, but the local gateway call sign. Well, what's the local gateway call sign? It's the local repeater call sign with a G in that station ID position, in the 8th position. Real simple. It's defined in the specification. This is defined in the specification. But now, that tells the local repeater, not only do you want to rebroadcast this locally, okay, because a repeater does a repeater. It rebroadcasts locally, okay? But you also want to send the bit stream to the gateway. And the gateway is going to look at it, going to look at your call, and either going to go, not worry about it, or it's going to say, oh, I know where that person is, and send the bit stream over to the remote gateway where that person is, currently has checked in by Kerchunking once, maybe 3 days ago. Doesn't matter. Still remembers where he was. All right. That's basically the deal. Key routing factor is in bold down there at the bottom. Routing, and I can't repeat it enough, routing is unidirectional. This is routing, not linking. And it is not source routing. I'm not saying how I'm going to get to him. Okay? I'm just saying I want to talk to him, and you network figure out how to get there. Guys, when you set up your computer at home, I don't care whether it's Linux, OS 10, or Windows, or whatever, okay? You tell it what your IP address is, and you tell it what the gateway is. Right? You're telling it how to get out, and then when you want to go surfing the web or whatever, you say what IP address you want to talk to. It's in essence what we're doing here. We're saying what our call sign is, what the call sign is that we want to talk to, and we're saying who the gateway is that we want to talk through on our end. in the local end. And then he, at the other end, when he does his one touch, the only thing that gets changed on his radio is who he's talking to. It's the only thing that gets changed. Who he's talking to. Because his radio is already set up to talk to the repeater and talk to the gateway. All right. What are some of the ICOM enhancements? Before I move into the ICOM enhancements, is everybody pretty comfortable with what we're talking about here? And everything that I've talked about is voice, works for data too. Okay? In other words, if I want to telnet or HC back and forth between his station and mine, as long as I have his IP address and his call sign, then we're going to be able to talk because the key part is this call sign. Okay.
So for that routing,
if you're trying to access a remote repeater, not the local repeater, but one that's
Right.
far away, and you're using the /G, are you able
It's
to?
not a /G, it's a G.
Or the G. Well,
Okay. It's the idea of the G. Yes.
are you able to monitor that
No.
remote repeater? So if you don't know who you want to talk to, you can't say, well, what's going on in Atlanta right now? You
Nope.
got to know it's Joe Blow.
Or the other part of the call routing, which I'll mention, and that's a good question, is what's known as a zone call. Zone call is the repeater call sign preceded by a /. So if I wanted to talk to a repeater in Atlanta, I can put in that repeater's call sign preceded by a /. Now I said that all call signs are 7 characters plus an ID character, right? Well, if I put the /, what happens to the repeater call sign? The repeater call sign follows that / to fill in the 7 characters. Okay, and then you have the ID for the repeater. That means the repeater call signs can be a maximum of 6 characters for that to work, because you can address them as a zone. But that's how you call into a zone. Now, what happens if that zone is busy? What happens if that repeater is busy? Okay, fine. Guess what? Your call didn't go out. And you get an indication back on your radio that the other end was busy. Now, it's a little bit convoluted in the current ICOM world, but there is an indication that comes back to your radio that the other end was busy. Okay? Same thing if I tried to talk to him and he was on a repeater that was busy at the time, that transmission of mine doesn't go out. It's not delayed and it's not storing forward. It's either gets to go out or it doesn't get to go out. Okay?
if I use that, will I hear what's going on?
Nope. Absolutely not. You will be able to make a call, and if somebody wants to respond to you, they will. If they don't want to respond to you, they won't. In other words, you don't control my transmission, I control my transmission.
So all I can do is hail, I can't listen.
That's right. You can call CQ. Now, there is a way to listen with things that Robin will talk about tonight and stuff with like the DV dongle and D+ and stuff, but that's outside of the D-STAR protocol.
I'm just talking about just using
I'm talking about with the D-STAR protocol and with D-STAR radios, and again, within the D-STAR protocol, no, it is unidirectional. You never say, I can never tell you where your signal's going to go. You tell yourself where the signal's going to go. That's very important. That is what our amateur radio is about, right? I can say where my signal goes. Now, propagation and stuff may say it's going to go further or whatever, but it's not because of what you did that's going to make my signal go further. And that's important. Okay? So this is like picking up a cell phone or whatever, and I call you. Guess what? You don't answer. You don't answer. I don't know whether you're there or not there. I don't know whether you heard me or not, so I might call you again.
Yeah, but at least his phone rings. With D-STAR, it doesn't even ring.
But I don't know that it's ringing.
But it does ring.
No. At the other end, if I call out there, he's going to hear my voice. What's better, him hearing a ring or him hearing my voice and saying I want to talk to that person or I don't? With D-STAR, he's going to hear my voice. Okay? In other words, on a cell phone, I call him, his phone's going to start ringing, right? Well, in D-STAR, I'm going to say, hello, 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 and he's going to hear my voice and say whether he wants to respond to me or not, whether he wants to answer. It's up to him to whether he wants to answer or not. Right? If he doesn't want to answer, that's fine. Doesn't mean I get to sit in and listen on to his conversation that he's already in the middle of. Does that make sense? Okay? Again, we're not linking. I'm calling you. You can respond to me and talk back to me or not. It's your choice, not mine. Yeah.
A couple questions. Gateway, is that a radio to internet link?
No. The gateway is a PC that's co-located at the repeater site that the repeater controller talks to and provides a bit stream path. In other words, the bit stream that goes into of the bit stream that's going into the repeater controller, and the gateway decides needs to go on to whatever gateway and then the repeater controller and such. That's never modified all the way through. The only thing that gets modified is the fields in the header that are allowed to by the spec. Because when it comes out at your end, it better show your repeater and your local gateway. All right? You should be seeing it. Still my call. My call and your call never change, okay? But you should be seeing the repeater. You should be seeing your local repeater and your local gateway. And by the way, the radios can be set so that if you see that come out, and you didn't know what the local repeater and local gateway call sign is, you can still do one touch and it's going to program your radio properly to respond to it. Yeah?
Can you extend the local network range with, I'm not sure what the right terminology would be, but say a satellite repeater that does not itself have a gateway, but is capable of talking back to a central system that does?
There is the ability to use the 10 gigahertz interconnectivity that's defined in the D-STAR specification.
Does that actually exist?
Yes.
The radios do?
Yes.
Okay. Yeah.
And it's used in Japan.
But
It's rather expensive, and to be honest with you, in the United States and most of the world, repeater sites are so easy to get internet connectivity to, even through wireless connectivity to the repeater site, that most people can't see the expense of a 10 gigahertz connectivity. It's easier just to throw a gateway in and be done with it.
So you're better off using some system outside of D-STAR to do that bitstream linking.
Yes, if you're going to be trying to get back to, because what you're trying to do there is not get back to that central repeater site necessarily, but just get to the internet.
Right.
Internet connectivity.
Okay, thanks.
Yeah.
For the local repeater, in other words, you're the local repeater, and I'm talking to Joe over here through the local repeater. Does everybody else that's on that frequency and in the RF domain, they don't hear that?
Everybody hears it.
Everybody hears
This
it.
is amateur radio.
Okay.
This is amateur radio. There is no such thing as a private communication.
Okay, but I thought you. So I guess I missed the key because you said the header says I'm talking to that guy.
The header says that's who I want to talk to, where my bit stream should be routed to.
Okay.
It's not who can listen to it, it's who it's routed to.
Okay. So everybody on the RF frequency then hears everything that's going into and out of that.
That repeater.
Okay. Or
Including, if I was talking to you from Dallas, they would hear me.
right.
But if they're talking, I would never hear them. And the reason is, I should be able to make a call into Chicago, but I should not be able to interrupt the Chicago conversation and take it over. And that's basically, by not being able to hear unless somebody responds, I'm putting out a CQ, and that's all it is. I'm putting out a CQ.
Okay.
Even to an individual station, I'm still putting out a CQ to that
Okay,
station.
and then I assume that you can, or you can set up the radio such that if I'm talking to him, that's all I want to hear. You know, you can put a, quote, squelch on everybody else if you want to.
You can put a call sign squelch on so that you only hear a particular station,
Okay.
yes. Yes. In the radios, they do have that capability, and that is defined in the ICOM enhancements. Okay? But that's call sign routing. I want to move on real quick with the ICOM enhancements because it is important to understand what is ICOM and what is the protocol. What we've talked about up to this point is completely protocol. It's completely protocol. ICOM has implemented a lot of it in their gateways and repeaters and stuff, but it is the protocol specification. It is not ICOM's. And I want to make that difference. Now, what ICOM has done is they've been able to allow you to put in a nice, hi, how are you type of front panel message. And that's all it is, folks. It ain't nothing special. And it is encoded so that you do not have access to it from a standard radio to change other than through the front panel. You can't change that message through, you can change it through software by programming the radio, but there is no like serial port or anything to change that message. It is set into the radio. It is only for digital voice. Digital data is real simple. I mean, digital data is an Ethernet packet going inside of encapsulation. That's it. Which, by the way, is a lot more efficient than an AX25 encapsulation of IP. Just if you were thinking about maybe putting it down on 440 or something like that, because all you got is that RF header and then the Ethernet packet, period. That's it. So it's pretty efficient encapsulation. In a low noise environment. If you're in a high noise environment, then the packet may be a better solution. Serial data. They implemented a thing called serial data. This is not a direct access to those data frames in the digital voice. This is an encoded in the digital frame that allows you a maximum of 740 bits per second on an unprotected 4800 bit per second data stream. What that means is if there's a bit error, and at 4800 bits per second, you're more likely to get bit errors than at 1200 bits per second, okay? If you get a bit error and it happens to fall in one of those data frames, guess what? The data that's going in that data frame is probably invalid. All right? Pure and simple. So what is the noun in digital voice? Voice. All right. But you can use it for serial data for minimal things that are in conjunction with the voice. One of the great things is that every time my wife keys up the microphone, I know where she is. Because hers is set up to send the GPS information. Every time she keys down the mic, not only is she talking to me, but she's continuously sending her position. Guess what? Doesn't matter. Because it's interleaved in the entire bit stream. Doesn't hurt anything to be interleaved in the entire bit stream. It's all part of her transmission. It's all an integral part of her transmission. Now, why is it important that it get repeated? Well, let's see. That's unprotected data. There's forward error correction in voice. I'm sitting here talking, having a perfectly legible conversation with her. And maybe two of those GPSA lines, packets, whatever, gets through, unadulterated. The rest of them have bit errors. And she was talking for a minute. My wife does pretty good about keeping her transmissions relatively short on amateur radio. But only one or two, perfect. I never noticed any problem with her voice, because the voice has forward error correction built in. We don't on the data side. That's why it has to continuously repeat. So we do get a valid string. Summary. I don't care what you hear, the protocol is well defined. Just because you can't read Japanese, as they say in Texas, ignorance is not an excuse for breaking the law. And trust me, if you ever get pulled over and try to use the ignorance excuse, you may find yourself in one of the places in Texas you really don't want to find yourself at. Bottom line is, protocol is well defined. Can you add enhancements? Can there be things there? Yeah, you can. Are there some holes in it that possibly implementations as this has gone on need to be better defined? Yeah, they do. But it is a well-defined protocol. Yes, sir.
Yeah, you said the protocol is well-defined.
Yes.
And maybe you're excluding the voice encoding because...
No, I'm not. Voice encoding is well-defined. If you want to ask why, this isn't the place. Okay? It is well-defined. You just don't know it. Okay? Real simple. I'm going to leave it at that. That's all we're going to say.
It's secret.
No, I'm saying it is proprietary to AMBI, but it is well-defined. And it is well-defined within AMBI. Okay? Again, let's leave that aside, and please respect the presentation. Let's leave that as it stands. If you want to discuss it later, we can. But for this discussion, it is well-defined. It's just that you don't know the definition. Okay, let's go on. It is a digital protocol. It is not a data protocol. Okay? There is digital data, which is the Ethernet encapsulation. But just because it's digital doesn't make it data. It is a digital protocol. It uses call sign addressing. Call signs are our IP address, for instance. Okay? Same type of thing. All right? Same equivalency. It's our telephone number. Our call sign is our telephone number. It's about time we started using our call sign for something else other than saying that's who I am. The ICOM enhancements are primarily in the digital voice world. The ICOM enhancements do not break the protocol. They make use of the protocol to the best of their ability. There's a high growth capability here. There's a lot of RF advantages and things like that that go along with it. It could be the next single sideband. If we try to break the protocol, it could be the next AX25, which we all try to find uses for those nice old TNCs that we have, either with whatever niche application we can. I'd rather see it become something that becomes widespread. Is it already becoming widespread? The answer is yes. There are currently over 200 repeaters on the worldwide network that are reporting their position to us. There's actually over 300 that are part of the worldwide network, and that's inclusive of the, I think it's about 35 Japanese repeaters that are also now part of the worldwide network. Thank you very much.